project is Government Website Access, Log Parsing, and Visualization. This is a team consisting of myself, Jason, Danish, and Jing. As an overview of our project, we want to use MapReduce to parse website access logs from 1.usa.gov in order to visualize and gain insight into website visitors. The visualizations we created are created with contemporary web technologies. So our source data are entries of data that are created whenever someone uses the bit.ly URL shortening service to link to a .gov or a .mil website. This data is available as an hourly report from bit.ly, and it comes in the JSON or JavaScript object notation format. So as kind of a visualization of what that JSON data looks like, we have, here's just the top of the stream for some given time period where we can see all these fields, one visit per entry. More in depth, we have their user agent or the web browser, we have the target URL, we have the timestamp, the latitude and longitude, city name, time zone, and a couple of other interesting things. So this is the data that we've been working with to parse and create visualizations. From an overall data flow perspective, we have that source data that is accessible through bit.ly. We wrote a process to pull that data in to HDFS. We wrote several MapReduce jobs, which would also output back to HDFS. And then in terms of accessing the visualizations, these are hosted directly on the Amazon S3 service, and in some cases we also have an intermediary Tomcat servlet which we used to massage data between CSV and JSON format depending on the visualization that needed it. So overall, some of the MapReduce jobs we had to make are the geographical distribution, which answers where are website visitors located, what are the top referring URLs, meaning what URLs are linking to these bit.ly.gov and .mil sites, what browsers are people using, and how many visits are sites getting over time. Also, can we correlate usage patterns that are out of the ordinary to external events? Here's an overall look at sort of a top-in MapReduce pattern. So like when we needed to generate the top referring websites, this would be a MapReduce job where we initially process the data into another format more conducive to processing with MapReduce, and then multiple mappers take the top in entries and then I'll send that to one reducer to just generate the final top-in sorted entries that we wanted to have in a data file for a visualization. In several cases, we had to chain multiple MapReduce jobs together in order to get the results we wanted. For example, looking at outliers of data for a given day and then looking over those for a longer time period. Here's an example of some of the generated data for geographical distribution visualizations. You can see in the top we have world map visualizations rolled up by month or rolled up by day, and in the bottom we have the same thing but for the US. So the technologies we use to actually make the visualizations, we researched things, different technologies we'd like to use. We came up with the Google Data Visualization API, which is basically a combination of HTML, JavaScript, and Flash. And we also came up with the D3 JavaScript library, D3 being data-driven documents, and this is also centered around HTML and JavaScript, but also SVG and CSS with no Flash. Here's a screenshot of what the geographical distribution visualizations look like. You can see on the left we have a world view. We can select different months that we want to see just by clicking on them. On the right side of the screen we have geographical distribution for just the United States, which uses that data we process by state you saw a couple of screens ago. Here's the visualization, a bubble chart showing top referring URLs that are non-normalized, and by non-normalized we mean, for example, see on the right side of this screen, HTTPS and HTTP : www.facebook.com were considered different URLs because the way this job processed them, those are just different strings from each other. You can see that the bulk of the referring URLs actually isn't a referring URL at all. It's just a direct entry, meaning someone typed in that URL. Here's a chart generated as with the previous one using D3 to help with converting the data into SVG. This one shows browser usage over time, so we can see starting in September 2012 what the usage of different browsers was, and then by month proceeding into April of 2013. Here's another visualization. This one's actually using the Google Data Visualization API, not D3. This one shows overall visits in the top left to both to several of the main websites, NASA.gov, FBI, and the White House. And then in the lower right, we can see the FBI.gov, an outlier in their data around April 19th. We had several observations based on our data and the visualizations of the process data as we worked through this project. One that was that NASA.gov was the most visited among all other government websites. FBI.gov had huge spikes during the Boston tragedy event that happened recently. Most of the traffic comes from Washington, D.C. The majority of people seem to get into the government websites by typing in the URL directly, and Facebook is the top referral website. That's all. Thank you for your time.